Now, in this video, we're going to focus on nomenclature, how to name compounds. So, the first thing you need to know is if you have an alkane with one carbon, this is called methane. An alkane with two carbons, C2H6, this is called ethane. If you have three carbons, C3H8, it's called propane. C4H10 is butane. C5H12, that's pentane. 6 carbons is hexane, 7 is heptane, 8 is octane, 9 is decane. 9 is nonane, excuse me. 10 is decane. So, how would you name this compound? Every endpoint represents a carbon. So this is going to be 1, 2, 3, 4, 5. So 5 carbons is pentane. Now what about this particular compound? Let's say if we draw a line there. This is called a methyl group. It's a substituent. So instead of saying methane, you add a YL at the end for any substituent. Now how can we name this compound? So the methyl group is on carbon 2. So the parent name, the longest chain, is still 5 carbons, so we still have pentane. So this is going to be called 2-methyl pentane. So how would you name this particular compound? So let's count the carbon atoms in the longest chain. There's 6 carbons. So the parent name is hexane, and we have a methyl on carbon 3. So this is called 3-methyl hexane. Now what about this one? So let's count the longest chain. So this time it's 7 carbons, so that's heptane. But notice that the substituent has 2 carbons. So 2 carbons is ethane, but as a substituent we need to add the suffix YL. So instead of saying ethane, it's going to be ethyl. So this is 2-ethyl heptane. Now what about this one? The longest chain has 8 carbons, and we have a methyl group on 3 and 4. So we have 2 methyl groups. So it's going to be called 3,4 dimethyl octane. So whenever you need to separate two numbers, use a comma, and use a hyphen or a dash whenever you need to separate a number and a letter. So feel free to pause the video and go ahead and name this particular example. So if we count the carbons, the longest chain has 7 carbons, so that's heptane. We have a methyl on 2 and an ethyl on 3. So which one is going to come first? Is it methyl or ethyl? So whenever you're choosing which substituent you should write first, look at the alphabet. E comes before M. So ethyl comes before methyl. So to name it, it's going to be 3-ethyl dash 2 dash methyl, and then the parent name heptane. Go ahead and name that particular example. So always find the longest chain. And this time, there's 9 carbons, so that's nonane. And we have 2 methyls and carbon 3. So this is going to be 3, comma 3, dash dimethyl nonane. How can we name this particular structure? So should we count it this way? 1, 2, 3, 4, 5. Now notice that we have 5 carbons if we count it that way. But if we start here, 1, 2, 3, 4, 5, 6, we'll have a longer chain. And so you want to count in such a way that you get the longest chain. And this group over here becomes a methyl group. So this is going to be called 3-methyl, because it's a methyl on 3. And since the longest chain has 6 carbons, hexane, or 3-methyl-hexane. Now what about this one? How should we name it? And which direction should we count it? Should we count it from left to right? 1, 2, 3, 4, 5, 6, 7, 8, or should we count it the other direction? If we go from left to right, the methyl groups will be on carbon 3, 6, and 7. Now, if we count it in the other direction, 1, 2, 3, 4, 5, 6, 7, 8, notice that we'll have lower numbers. It's going to be, instead of 3, 6, 7, it's now 2, 3, and 6. So you want to count in the direction that's going to give you the lower numbers. So we can go ahead and name it. There's 3 methyls. We have a methyl on carbon 2, 3, and 6. So it's 2, 3, 6 trimethyl octane. Now what about this one? How can we name it? For this particular example, it doesn't matter which direction we count it, because if you count it in either direction, you're going to have a methyl on 2, 3, 4, and 5. So to name it, it's going to be 2, 3, 4, 5. Since we have 4 methyls, it's going to be tetramethyl. And the parent chain contains 6 carbons, so hexane. Tetramethyl-hexane. Try this one. So first, we need to identify the longest chain. 1, 2, 3, 4, 5, 6, 7, or this could be 7, 8, or if we count it this way, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the longest chain. So on 7 we have a methyl. There's a methyl on 5, and on 4 we have an ethyl. So And we got to make sure we're getting the lowest numbers. So if we count it the way we have it, it's going to be, we have a group at 4, at 5, and at 7. Now if we count it the other direction, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll have a methyl on 3, another methyl on 3, and an ethyl on 6. So 3, 5, 6 is lower than 4, 5, 7. So therefore, we want to use the purple numbers. So it's going to be, we got to start with ethyl because we need to alphabetize it. So 6 ethyl dash 3, 5 dimethyl because we have 2 of them. And then there's 9 carbons in the longest chain, so nonane. Now, there are certain substituents that you need to know. So, as you mentioned before, this is methyl, ethyl, propyl, and 4 is for butyl. This is isopropyl. This is isobutyl. And this is isopentyl. So isopropyl has 3 carbons, and at the end, notice that there's 2 methyl groups. It splits off in 2 directions. The same is true for isobutyl. It has a total of 4 carbons, and at the end, it splits off. And for isopentyl, the same is true. Now, this is called sec-butyl. It has a total of 4 carbons. And this last one here, this is tert-butyl. So these are some names that you want to familiarize yourself with. So how would you name this particular compound? So the longest chain contains 7 carbons, and we have an isopropyl group on carbon 4. So it's 4 isopropyl heptane. Now what about this one? So on carbon 4, we have a tert-butyl group. So to name it, this is going to be 4 tert-butyl nonane. Now sometimes you might have complex substituents. So let's say if we have something like this. Well, actually, right now that looks like sec-butyl. But what's the IUPAC name? Well, let's write the common name and the IUPAC name. So if we count it from either side, the substituent is on carbon 5. Now it looks like sec-butyl. We could say 5 sec-butyl nonane. Or we can name the complex substituent. So this is carbon 1, carbon 2, carbon 3. For the substituent, the longest chain is 3, so it's propyl. But we have a methyl on 1, so it's called 1-methyl-propyl. So to put it together, the substituent is on carbon 5. So it's 5-1-methyl in parentheses. So 5-1-methyl-propyl, and then you close it. So that's for the complex substituent, and then nonane. Try this one. So let's count the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. But let's check it this way too. 6, 7, 8. So that's not going to work. So then the longest chain is horizontal. And what we have here is a complex substituent. So let's name the complex substituent. The longest chain there is 3, a propyl. And we have a methyl on 1 and 2. So just to name the complex substituent, it's going to be, in parentheses, 1, 2 dimethyl, because there's 2 methyls, and the longest chain is propane, but because it's still a substituent, we're going to say propyl. So now let's put it together. So the entire substituent is on carbon 5. So it's going to be 5 dash, in parentheses, 1, 2 dimethyl propyl nonane. What about that one? Go ahead and pause the video and name it. So let's count the longest chain. So we can also count it this way, 6, 7, 8, but that's not going to be the longest chain. So let's name the complex substituent. So it's propyl again, but this time we have 2 methyls on 1 and a methyl on 2. So it's going to be 5, and then the complex substituent, which is going to be 1, 1, 2 trimethyl, because there's 3 methyl groups, propyl, and then close parentheses. And for 10 carbons, the longest chain is decane. So go ahead and try that one. So let's identify the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, or we can count it this way, 6, 7, 8, 9. So the 2 chains are equal. So which route should we take? Should we go this way, or should we go this way? Now you want to go in a direction that gives you the greater number of substituents if you have 2 chains of equal length. So if we go to the right, we're just going to have one big complex substituent. But if we go up, we're going to have a methyl group, another methyl group, another methyl group, and this that butyl group as well. So we want to count going in the upward direction, because it's going to give us more substituents. So this is going to be 6, 7, 8, 9. So we have a methyl on 6, a methyl on 7, and a methyl on 8, and a butyl group on 5. So now let's name it. Butyl comes before methyl if we alphabetize it. So it's going to be 5 butyl dash 6, 7, 8 trimethyl nonane. Now, the next thing we need to talk about is alkenes. So how can we name this particular alkene? Alkenes have double bonds. They're unsaturated compounds. And so first you want to identify the longest chain. So it's 5. Instead of saying pentane, it's going to be pentene. And a double bond is between 2 and 3, so this is called 2-pentene. Now, what if there's 2 double bonds? How would you name it now? So this is 1, 2, 3, 4, 5, 6, 7. So you won't use the double bonds on 2. You gotta it's between 2 and 3, but you gotta pick the lower of the 2 numbers. So we have one on 2 and 4. So this is going to be 2, 4. And then instead of saying heptene, it's going to be heptadiene because there's 2 double bonds. Now, how would you name this particular alkene? Should we count it starting from the left or from the right? You want to count it from the right because you want to give the alkene more priority than the methyl group. You want the alkene to have a lower number. So to name it, it's going to be 5-methyl. We have a methyl and carbon 5. And then -2. Now the longest chain has 6 carbons, so instead of saying hexane, it's going to be hexene. So 2-hexene. Now what if there's 3 double bonds? So we have a double bond on 1, another one on 3, and another one on 5. So this is going to be called 1, 3, 5 heptatriene because there's 3 double bonds. So whenever you have a triple bond, you have an alkyne. So the triple bond is between carbons 1 and 2, so it's going to be, instead of saying hexane, it's hexine, but particularly 1-hexine. So that's how you name alkynes. And we have a methyl on 4 and 5, so it's going to be 4, 5 dimethyl -1-hexine. Now the next thing we need to talk about is naming alkyl halides. So how would you name this particular alkyl halide? So we have a bromine atom on carbon 2. The parent name is pentane. So this is simply called 2-bromopentane. Now let's say if we have a chlorine on carbon 2 and a fluorine on the other side. How would you name it? And which direction should we count it? Should it be 1, 2, 3, 4, 5? Or should we count it the other way? If we count it this way, either case we're going to have a number on 2 and a number on 4. But do we want the chloro to be carbon 2 or the fluoro to be carbon 4? Because C comes before F, if you have a choice, you want the one that comes first to have the lower number, in this case chlorine. So we want to count it in the way that we have it. So it's going to be 2-chloro -4-fluoro pentane. If we count it the other way, it's going to be 4-chloro -2-fluoro. Chloro still has to go before fluoro. So if you can alphabetize it and put it in increasing order, this is what you want to do. So this is the right, this is the appropriate name. Now let's go back to alkenes. So how would you name these two alkenes? The alkene on the left is a trans alkene. Notice that the hydrogens are on opposite sides. The one on the right is a cis alkene because the hydrogens are on the same side. So to name the one on the left, it's going to be 1, 2, 3, 4, 5. We need to count it from right to left so that the alkene has a lower number. So it's going to be trans 2 pentene. And for the example on the right, it's cis, and if we count it, 1, 2, 3, 4, 5, 6. So it's cis 3-hexene. So when you have an alkene, you may need to mention if there's cis and trans. So now let's move on into cycloalkanes. So this is the ring with 3 carbons. This is called cyclopropane. This is cyclobutane, cyclopentane, cyclohexane, and this is cycloheptane, and this is the octagon, cyclooctane. So, how would you name this compound? And where should we start? So we can start with the methyl or the bromine. If we start with the bromine, it will be 1-bromo, 3-methyl. If we start with the methyl, it will be 1-methyl, 3-bromo. And Br comes before M, so we're going to assign the bromine carbon 1. Since we need to alphabetize it, we want to put the numbers in increasing order. So it's going to be 1-bromo dash 3-methyl dash, or not dash, but after 3-methyl, cyclopentane, because there's 5 carbons in the ring. Now, how would you name this? Now, it's automatically assumed that the double bond is going to be on carbon 1. So this is simply cyclohexene. You don't have to say 1 cyclohexene. It's just cyclohexene. Now, how would you name this example? So the double bond is going to be at 1. We can count it this way. 1, 2, 3, 4, 5, 6. We'll have substituents on 3, 5, and 6. Or we can count the other way. 1, 2, 3, 4, 5, 6. So in this case, it will be 3, 4, 6. And if we did it the other way, it was 3, 5, 6. So we want it the way it's written because 3, 4, 6 is lower than 3, 5, 6. So we'll keep it this way. Now the double bond is always going to be at 1, so we don't have to say 1 cyclohexene. It just, the ending is going to be cyclohexene. So now chloro comes before ethyl and ethyl comes before methyl. So let's put it together. So it's going to be 6-chloro dash 3-ethyl dash 4-methyl and then cyclohexene. So that's how you can name it. Try this example. How would you name this particular cycloalkane? So we have a methyl on carbon 1 and 2. But notice that one is in the front and the other is in the back. One is on the wedge, the other is on a dash. So this is going to be called, this is going to be trans because they're on opposite sides. So it's trans dash 1, 2 dash dimethyl cyclopentane. So now let's move on into bridge bicyclic compounds. So let's say if we have a structure that looks like this. How would you name it? So these tertiary carbons in red are the bridgehead carbons. The reason why they're tertiary is because each of those carbons are attached to 3 other carbon atoms. So those are tertiary carbons. Now, on this side, there are 3 carbons. 1, 2, 3. And in this link, we have 2 carbons. And over here is only 1 carbon. So to name it, it's going to be bicyclo, and in descendant order, 3.2.1, and there's a total of 8 carbons if you add the 2 bridgehead carbons. So if you add 3 plus 2 plus 1, and then add the 2 bridgehead carbons, is 8 carbons, so we're going to say octane. So that's how you can name a bridge bicyclic compound. So let's try another example. Try this one. So here are the bridgehead carbons. On this side, we have 2 carbons. And on this side, we have 2. And on the top, we have 1. So it's going to be bicyclo 2, 2, 1. So 2 plus 2 plus 1 is 5, plus the 2 bridgehead carbons is 7. So heptane. And finally, try this example. So here are the bridgehead carbons. On this side, we have 1, 2, 3, 4. In the middle, there's no carbons, so we're going to put 0. And on this side, 1, 2, 3. So it's bicyclo in descendant order, 4, 3, 0. 4 plus 3 plus 0 is 7, plus the 2 bridgehead carbons, that's 9. So nonane. So how would you name this particular compound? If you see an OH group, it's an alcohol. And there's a total of 5 carbons. So instead of saying pentane, it's going to be pentanol. And the OH is on carbon 2, so this is called 2-pentanol. Now, what kind of alcohol do we have? Is it primary, secondary, or tertiary? Notice that the alcohol is on a carbon that is attached to 2 other carbons. So this is a secondary alcohol. So let's say if we have an OH group here, a CH3, and a Cl. So we need to give the alcohol priority. So we need to count it from right to left so that the OH will have a smaller number. If we count it from right to left, the alcohol is going to be on carbon 3. If we go from left to right, it's going to be on carbon 5. So to alphabetize it, chloro comes before methyl. So this is going to be 6-chloro-4-methyl. And instead of saying heptane, it's going to be heptanol, but -3-heptanol. So the next functional group that you need to be familiar with is the carboxylic acid. Let's put a Br on it. So the carbon that is part of the carboxylic acid is always going to be number 1. And because it's always number 1, you don't have to specify the 1. So the 6 carbons, instead of saying hexane, it's going to be hexanoic acid. So this is 4-bromo hexanoic acid. The next functional group that you need to know is the ketone. So let's put a methyl. Actually, let's put an ethyl there and a methyl. So how can we name this particular ketone? So counting the longest chain, this is going to be 1, 2, 3, 4, 5. And we have an ethyl on 3, methyl on 4. So it's going to be 3-ethyl dash 4-methyl. Now instead of saying pentane, it's pentanone because we have a ketone and it's on carbon 2. So it's going to be dash 2 pentanone. So the suffix is one. How about this one? Go ahead and name it. So the aldehyde is going to be on carbon 1. And it's always at the end, so we don't have to specify the 1. We have a chloro on 4, an iodo on 3, but C comes before I. So this is going to be 4-chloro dash 3-iodo. And so we have 6 carbons. Instead of saying hexane, it's going to be hexanal. So 3-iodo hexanal. The suffix for an aldehyde is Al. For an alcohol, it's Ol. So now sometimes you might have more than one functional group. So let's say if you have a carboxylic acid. The carboxylic acid has the highest priority of the common functional groups. So let's put a ketone, let's put a hydroxyl group, an aldehyde at the end. Let's add this one, an NH2, and I think that's about it. So the ketone and the aldehyde, it's called an oxo group as a substituent. Now the alcohol, the OH group, it's called a hydroxy group. OCH3 is methoxy, and OCH2CH3 is called ethoxy. Now the NH2 is an amino group. So let's put this together. So how would you name this particular compound? So the carboxylic acid has the highest priority. Next in line is the aldehyde. So we have an oxo on 4 and an oxo on 5 and a hydroxy on 4. So H comes before O. So this is going to be called 4 hydroxy dash 5 oxo and then hexanoic acid. Let's try another example. So here we have the aldehyde. We're going to put an OCH3 group and an OCH2CH3 group. And let's add an NH2 group. So the aldehyde has more priority than the ethers and the amine. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8. So the amino group comes first. A is the first letter in the alphabet, so it's 4-amino, And then ethoxy comes before methoxy, so it's going to be 5-ethoxy dash 6-methoxy. And then instead of saying octane, it's going to be octanol with an AL at the end. Now let's talk about ethers. This is called, the common name is dimethyl ether. This is diethyl ether because there's two ethyl groups on both sides. Now what about this one? How would you name it? Now on the left side we have a methyl group, and on the right side we have an ethyl. So if we alphabetize it, this is going to be called ethyl methyl ether. So now let's focus on the IUPAC name. So for diethyl ether, it looks like this. So what we could do is, the longest chain is 2 carbons, and so on the other side we have an O and then a CH2, CH3. It's easier if you see it that way. So this is carbon 1, this is carbon 2. So this is called an ethoxy group. So it's just going to be called ethoxy ethane. Because it's only 2 carbons, the ethoxy group has to be on carbon 1, so we don't have to specify. So now let's say if you have an ether that looks like this. So the longest chain is this one, 1, 2, 3, 4. So what I would do is I would redraw it. It's easier if you see it this way. So the ethoxy group is on carbon 1, so this time you got to specify it. It's 1-ethoxy, and the longest chain is 4 carbons, so 1-ethoxy butane. So now let's say if you get an ether that looks like that, how would you name it? So draw the longest chain, which is this group, and on the first carbon we have, instead of a methoxy or ethoxy, it's a propoxy group because there's 3 carbons on the right side, 1, 2, 3. So the longest chain is 1, 2, 3, 4, 5, so it's pentane, and we have a methyl on 3 and 2, so this is going to be called 2, 3 dimethyl dash 1 dash propoxy. M comes before P. So 2, 3 dimethyl dash 1 propoxy. And then pentane for the longest chain. So now you know how to name ethers. Now say if you have the chair conformation of cyclohexane, and we have a methyl and a bromine atom. How would you name this compound? So let's start with the BR. This is carbon 1, 2, 3, 4. Now is it cis or trans? Notice that the methyl group is in the axial up group. It's in the up position. But the bromine atom is in the axial down position. Because one is up and the other is down, this is the trans isomer. So it's going to be called 1-bromo dash 4-methyl. But we need to put a trans before it. So it's trans 1-bromo 4-methyl cyclohexane. Try this one. So we have an alcohol on 1 and a chlorine on 3. Now the chlorine is in the up position, it's in the axial up position, the OH is in the equatorial down position. So because one is up and the other is down, it's trans again. So it's trans 3-chloro. And we don't have to say 1-cyclohexanol because the OH is going to be on carbon 1. So this is just 3-chlorocyclohexanol. Now let's say if you have this compound and let's say the Br is in the front. How can you name this particular alkyl halide while specifying stereochemistry? So right now we know that it's 2-bromo pentane. The bromine is on carbon 2 and there's 5 carbons total. So let's write that, 2-bromo pentane. The last thing that we need to do is we need to determine if we have the R stereoisomer or the S isomer. So if the bromine atom is in the front, that means the hydrogen is in the back. So bromine is number 1, it has the highest atomic number. Next we have the propyl group, there's more carbons there compared to the methyl group. And hydrogen has the lowest atomic number, so it has the lowest priority. So if we count it from 1 to 2 to 3, we're rotating it clockwise, so we have the R isomer. So it's going to be R 2-bromo pentane. Go ahead and name this particular compound. So to get the lower numbers, we want to count it from left to right. So the Cl is going to be on carbon 2 and the Br is going to be on carbon 5. If we count it the other way, the bromine will be on 3, and the Cl will be on 6. So this is carbon 1, 2, 3, 4, 5, 6, 7. So it's 2-chloro. Actually, bromine comes before chlorine. But we still need to count it from left to right so we can still get the lower numbers. So it's going to be 5-bromo dash 2-chloro. And there's 7 carbons in total, so heptane. So now, let's identify the chiral centers. So these are the 2 chiral centers. A chiral center is basically a carbon that has 4 different groups. Now for the chlorine atom, because the chlorine is in the back, the hydrogen is in the front. Now whenever you want to assign the RNS configuration to a chiral center, the hydrogen must be in the back, so we're going to have to reverse it. So chlorine has the highest priority, then it's everything on the right side, that's group number 2. Then we have the methyl, and H is almost always number 4. So if we count it from 1 to 2 to 3, it appears to be R, but because H is in the front, we need to reverse it, so it's counterclockwise. So therefore it's S. Now over here, the hydrogen is in the back because the bromine is in the front. So this is number 1. The group on the left is 2, the ethyl on the right is 3, and H is 4. So we don't have to reverse it here. So going from 1 to 2 to 3, we can see that we have the R isomer. So carbon 2 has the S isomer, carbon 5 has the R isomer, so it's going to be 2S, comma, 5R, and then dash 5-bromo 2-chloroheptane. So as you can see, the chiral center where the Br is has the R isomer because it's 5R, and the carbon that has the chlorine, that chiral center is S. Chlorine's on 2, so it's 2S. And so that's how you can name it. So how can we name this compound that is represented using a Fisher projection? So before we focus on stereochemistry, let's get the general name. So this is going to be number 1, number 2, number 3, 4, and 5. So it's 2-bromo dash 3-chloro, and there's 5 carbons in total, so pentane. So now let's consider stereochemistry. So let's get rid of these numbers. So here's the first chiral center. Now, the groups on the left and on the right, for the Fisher projection, you can treat them as if they're in the front. So anytime you see hydrogen on the side, you're going to have to reverse it. Bromine is number 1. This entire group with the chlorine on the bottom, that's going to be number 2. H is number 4. Methyl is number 3. So if we count it from 1 to 2 to 3, ignore 4, it appears to be rotating clockwise, so that's R. But we got to reverse it because hydrogen is on the wedge. So this is going to be S if we reverse it, because now it's counter clockwise. So let's put S. Now for the other chiral center, the Cl has the highest atomic number, so that's 1. And if you compare the Cl and the Br, first you look at the chlorine and first you look at the carbon. You look at the first atom that's attached to the chiral center. And so chlorine has a higher atomic number than the carbon above, so that's why chlorine is number 1 and not bromine. So this entire group above is going to be number 2. The ethyl below it is number 3, and H is 4. So going from 1 to 2 to 3, ignoring 4, it appears to be R, but we'll need to reverse it, and so it's S. So we have 2s chiral centers. So it's going to be 2s, 3s dash 2-bromo 3-chloro pentane. So now you know how to name a compound that's presented in a Fisher projection.